Okay, let's do the configuration on area 3, and I have configured these routers with basic IP address information. So I'm going to go back to router 4 first of all, because I'm going to put Ethernet 1 into area 3, which means that I'm going to be a little more specific. So let's go back to router 4. On router 4 you can see that this is a configuration of OSPF, and I'm going to go back to here, and here I'm going to say no network this, and I'm going to show IP interface brief first of all. Instead I'm going to say network 10.14/24 is in area 0, and also 24 is in area 0. I don't need to go with 4, I can just go with 0. This means that if I commit, of course this is not going to give me an error, but normally because I'm using 24 bits, so this would be more tangible to be 0. It doesn't really matter. But this one, this 144, is going to be in area 3. So I'm going to configure this with area 3, and I'm going to say commit, and also I'm going to save the configuration. Okay, let's go back to router 14. On router 14 I have configured this, and all the interfaces can be in area 3. So what I'm going to do is to say router OSPF1. Router ID of course is going to be this. But again, if I hadn't configured this, is going to be configured for me. I'm going to say network this /24 is in area 3. And also network 129 is going to be in area 3. So I'm going to say commit, and just showing the running configuration is going to tell me that I have this configured here. And I'm going to save the configuration as well. The same thing is going to happen to router 15. So I'm going to say router OSPF1, router ID is going to be 15. And networks are going to be this one, 129/24 in area 3. And also 131, I'm going to just advertise this. And one thing that I want to do is to say that although this interface is between router 15 and 16, and I have just advertised it into OSPF, I don't want this interface to be part of OSPF adjacency process. So this means that I'm not going to create any neighborship with other networks, but I just want to have this network inside my OSPF database. So I could do this in two different ways. I can just redistribute this route using redistribute connected, or I can just add it to OSPF process and then say passive interface, which I'm going to do is right now. I'm going to say passive interface what is the interface? ETH1. So with this passive interface ETH1, and I would say enable passive interface. Okay, that's it. And I'm going to say commit. Now that I haven't done this, I need to clear the IP OSPF process first. Okay, so it is not allowed to do, so I'm going to say do WR first of all, and then I'm going to say end, and then I'm going to, oh, that is a problem. There was a quotation mark in the beginning, which I just kept adding it. Okay, so if I say show IP OSPF database, now I have a link from 15. Okay, now I have full information inside here. Okay, so you see that I have received information from different areas, specifically even from area 2, which router 12 and 13 are inside. Again, I have only one exit point, which means that would be better to configure this as a stop, but there are some interesting cases here. I might have redistribution here. What I'm going to do is to say that I am redistributing from this BGP area later. Right now I'm not going to do this. I'm going to just say that this BGP, oh, maybe I should do this. I'm going to create a BGP adjacency between this and right now. So I'm going to go to router 15, go to configuration mode, and I'm doing just very basic BGP, and I'm going to explain everything later. But let's say that I'm going to say router BGP, and let's say that my network is going to be configured with BGP 100, just for the sake of simplicity. And here I'm going to say neighbor is 10.10.131.16, which is in remote AS 200. That's it. And I'm going to say save the configuration and commit the configuration. So let's go to router 16. Router 16 is to say router BGP 200, and I'm going to have a neighbor 10.10.131.15, which is in remote AS 100, and I'm going to redistribute everything that I have right now. So I would go to address family IPv4 unicast, and I'm going to redistribute connected networks here. So I'm going to commit. So if I try to check running configuration here for BGP, you could see that this BGP is created for me. And if I say do show IP BGP, it is going to tell me that all these networks are advertised into BGP. And if I say show IP BGP summary, it will tell me what neighbors are here. And one thing that I believe I should do is to activate the neighbor, because sometimes you have not. So I should just say neighbor activate under the address families. So if I just say commit and save the configuration, of course, I'm going to say show run. Let me see if this is something which is done by okay, so that is activated right now. Now I should do the same thing on the other side. So I'm going to say this neighbor should be activated. Address family IPv4 unicast. On some platforms IPv4 is activated by default, and that is why I was trying to see whether this platform is one of them or not. So what I'm going to say is show IP BGP summary, and now you can see that I have an adjacency with this. So if I just go back to router 15, say show IP BGP, of course. For now I have not received anything, and if I just say show IP BGP summary, I am in adjacency. Okay, now I have received all the prefixes. Very interesting. I might want to redistribute them into other areas. So I might want really to have accessibility to these networks here. So what I'm going to do is to say redistribute BGP into OSPF, and also I need to kind of give some information about my network to R16, which I'm going to deal with that later. But for now, I'm just going to do this. I'm going to go to router 15, and I'm going to go to router OSPF process. I'm going to say redistribute BGP 100. I just that's here. So redistribute BGP and that's it. No 100 or anything. So redistribute BGP and then hit enter. And I'm going to commit this. Now what is going to happen? I'm going to have all those prefixes from BGP, these three prefixes, let's say 16, 16, 16, 16, inside my OSPF database. So if I say show IP OSPF database and hit enter, you should really see there is an extra type of LSA which is created for me, and that is AS external, and you can see that which means that this is LSA type 5 as a matter of fact, and I have 16 in here. What is the advertising router? The ASBR. R15 is the advertising router. If I go to router 14 and say do show IP OSPF database and hit enter, you can see that we have type 5 here, AS external 1616. If I go to area 0 routers, let's say router 1, and I'm going to log in again, and I'm going to say show IP OSPF database here, you can see that type 5 is still here. Okay, so this is a good option. This is kind of a stub area, but not so a stub area, so I cannot really configure this like area 2. So I'm going to go with not so stubby configuration. Again, I should do this on all of these routers. So I'm going to go to router 15 first of all, and I'm going to say that router OSPF 1 area 3 nssa. The same thing should happen on others, so I'm going to commit this. So I'm going to just copy this, go to 15 and go to router 4, which is my ABR. OcNOS en configure terminal, and that's it. So now that I have done this, if I go back to router 14, check the database, what do we have? It is going to take a little while to converge, and after some time I should have full database here. To show IP OSPF neighbor, I am in XStart right now, which means that we are trying to exchange our database, and after some time I should see that we are in full mode. And of course this means that I have not configured this interfaces as point-to-point, which is better to be configured as point-to-point. Now if I check the database one more time, there's an interesting case in here. So instead of the type that we had, type 5, which was AS external, now we have nssa external, which is type 7 as a matter of fact. Now if I go up, we don't have a default route here. For now, of course, we should see it in a second. Let me just try it again. Okay, we don't have it. But the interesting thing is, now we don't have that is LSA type 5. That is on area 4. Let's go to router 15 and see it again. Show IP OSPF database. So you see that instead of having AS external, we have type 7, which is nssa external. On router 4, which is ABR, show IP OSPF database, things are a little different now. We have type 7, but when I go to router 1, show IP OSPF database, here I still see AS external. Why? Because ABR does not let any LSA type 7 go through it. What it does is it just translates type 7 to type 5. By default this is done. And type 7 LSAs are advertised as type 1 here. Also there is an external information which is type 4. And type 4, as a matter of fact, I'm not seeing it here, but type 4 is an LSA which says how we can get to ASBR, and that is called ASBR so I don't have it in here, unfortunately. That is going to be an LSA that says that how we can just get to the ASBR here. So show IP route, as a matter of fact, is going to show us that those links are not installed here, which we should have it, as a matter of fact. And the reason is we don't have accessibility to that. Maybe no, we do. So that is 134, and 134 is not in here. I'm going to check to see why. Do we have it on router 4, which is here? 134 is in here. So if I just say show IP route, 134 is in my routing table, and it is configured as in2, which is the metric type that we have for this, and also 16 is here. And if I just go to router 1 and try to show IP route, this one, it says that network is not in table. If I try to say show IP OSPF database, and the type that we are trying to see is ASBR summary, and that is the route. ASBR summary. Okay, it said that we don't have it in here, but now the ASBR summary may be nssa external. Do we have it? That is AS external. So that should be AS external, and let's go with external. External. Okay, now we see that this is an external network, and I have the advertising router here, which is router 15, and the metric is larger than any link state path. That is the reason that we don't have it in our network table. I'm going to fix this problem again, but for now what I'm going to do is to go to router 4, and I'm going to change the configuration a little bit. So if I say show run, here you can see that this area 3 is nssa. Now I'm going to say this is nssa no summary. No summary means that, again, we don't want to send any summary to there, and of course we can just configure default information. In here you can see that the reason that we didn't see 0000 in there, that was because we didn't have any default information here. I'm going to check to see if I just change this, what we are going to have on router 14. So I'm going to check the database one more time, and you can see that after some time all these type 3 summaries have been withdrawn. All I have is 0000, which means that again I have accessibility to other parts of networks, 10.13.3 for example, and of course with the do in the beginning, which is accessible, and everything seems to be fine. Going back to router 1 and checking show IP route. So I have accessibility to router 13 as well, router 14 as a matter of fact, which is going to be 129, sorry, and also 131 is there by default. Okay, so we have just received the information from the other side, and the interesting thing is because this was an nssa, we don't have to, of course, say no summary on these routers because these are not by default ABRs. The only ABR that we have is router 4, and router 14 and 15 have received the default route, but because router 15 has a specific feature, which is this is an ASBR. Now this is generating LSA type 7s, and also area 3 now should be marked as nssa because we want to say this is a sub, but not really stubby. And it is not, of course, necessary to change this type of network to nssa. One of the reasons that I'm doing this is I might really want to decrease the amount of information that these routers have to handle. You should know that in OSPF networks, ABRs are going to be more important, so they should be more stronger than other routers inside an area, because ABRs are going to process multiple databases. You can see that router 4, router 3, these are processing area 0, they are processing area 2, and for router 3 or router 4, of course, area 3. This means that they are going to handle extra information. If they are connected to multiple areas, then they are going to have multiple databases. So ABRs should be a little more intelligent, more resourceful, but when we have routers that have little resources, then that would be a good idea to put them inside some other areas. And of course, if they have they are configured with stop or nssa in case they really are not part of our transit network, then that would be a good idea to do that. So I'm going to continue the configuration of my OSPF network in the next video.